And now in this lecture, we'll answer two questions. On both questions, we'll find out the area of a trapezoid. So we start with the first question. But first of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. Trapezoid ABCD is a quadrilateral with side AB that is parallel to the opposite side DC. Therefore, this quadrilateral with one pair of parallel sides is defined as a trapezoid. The two parallel sides, that is AB and DC, are defined as the bases of this trapezoid ABCD. So the first base is AB and the second base is DC. If we define the length of AB as B and the length of DC as A, and what is the area of trapezoid ABCD? We get that the area of trapezoid ABCD will be equal to A plus B, that is the sum of its two parallel bases, times the height edge over 2. Again, the area of any trapezoid is equal to the sum of its two parallel bases times the height over 2. The height edge must create 90 degrees with the two parallel bases. You can see here that the height edge creates 90 degrees with the base AB, and the height edge also creates 90 degrees with the base DC. So a trapezoid is a quadrilateral with one pair of parallel sides, and the area of a trapezoid is equal to the sum of its two parallel bases times the height over 2. The height must create 90 degrees with the two parallel bases. Okay, so we start with the first question. In the drawing, we have trapezoid ABCD. It is given us the question that side AB of this trapezoid ABCD equals to 2 units in its length. Also, we know that side DC is equal to side BC. Those two angles are right angles. Again, our mission is to find out the area of this trapezoid ABCD. And the most important thing that is given us in the question is that the perimeter of this trapezoid ABCD is equal to 16 units. That is to say, the sum of the lengths of all the sides of this trapezoid ABCD is equal to 16 units. Again, a perimeter is the sum of the lengths of all the sides of a trapezoid. And we know that the perimeter of this trapezoid ABCD equals to 16 units. That is to say, AB plus AD plus DC plus CB, in total it is equal to 16 units. That is actually the perimeter of this trapezoid ABCD. So I write it down according to what is given as the question. AB plus AD plus DC plus CB is equal to 16. The sum of all the sides of this ABCD is equal to 16. That is the perimeter of this ABCD. Okay, again, AB plus AD plus DC plus CB equals to 16. AB is 2 plus AD. AD is the missing side, so we define side AD as A. That is to say, AD equals to A units in its length according to our definition. We define the length of side DC as B. And because of the fact that DC equals to BC, and DC is B, therefore BC must be also equal to B. So the perimeter of this trapezoid ABCD is 16. That is to say, AB that is 2 plus AD that is A according to our definition, plus DC is B also according to our definition, plus BC that is also B. In total, the sum of those four sides is equal to 16. This is the perimeter of this trapezoid ABCD. Here we subtract 2 from this equation and get that A plus B plus 2B equals to 16 minus 2, that's 14. Here we subtract 2B from this equation and get that A equals to 14 minus 2B. So if I know that A equals to 14 minus 2B, so if I know that A equals to 14 minus 2B units in its length. In the next step, we will do a construction. That is to say, from this vertex B of this trapezoid ABCD, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC. This point is point M. By doing this construction, we can do quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in size. So inside quadrilateral A, B, and D, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will add to this quadrilateral A, B, and D is a rectangle because it has 4 right angles. Quadrilateral A, B, D, M is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABDM, side AB must be equal to the opposite side DM. But AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the sum rule, in the sum rectangle ABMD, side AD must be equal to the opposite side BM, but AD is 8, it is equal to 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B units in its length. What is the length from this missing line segment? Line segment MC. For the door unit, it is very easy to see that MC in total equals to DC minus DM. Again, MC equals to DC minus DM. So I write it now. MC equals to DC minus dm. So MC equals to DC. DC is B according to our definition. Minus dm. We just like to find out that dm equals to 2. So in total, if you found out that MC equals to B minus 2 units in its length. So let's know MC equals to B minus 2 units. So in the next step, I'm copy this right angle BMC in the new page and represent the Pythagoras theorem on this right angle BMC. According to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is a derivation from Pythagoras theorem. So actually, this is the entire BMC that is the course from the original moment. According to the Pythagoras theorem, in this entire BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. So what is known? BC squared, that is the square of the hypotenuse, is equal to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So if we found out that B squared equals to 14 plus 2 B squared plus B minus 2 squared. So here we'll open the brackets on this side of the equation and we get that B squared equals to 14 minus 2B squared. 14 minus 2B squared is equal to 14 squared, that is 196, plus 2B squared, that is 4B squared, minus 2 times 14, that is minus 28, times 2B is minus 56B, plus B minus 2 squared. B minus 2 squared equals to B squared plus 2 squared, that is 4, plus 2 times B times 2, that is minus 4B. So on both sides of this equation we have B squared, so B squared will get cancelled. So in this side of the equation, after we cancel B, we left with nothing, that is to say 0. On the other side of the equation we have 196 plus 4, that is 200. And you also have 156b minus 4b is 160b. And we have here also 4b squared. So in total, we should hold on that 0 equals to 200, 160b plus 4b. Actually, plus 4b squared, of course. So here we divide this equation by 4, and you get that 4b squared over 4 is b squared, and we have also 160b over 4 is 115b, and finally we have 200 over 4 is 50, and it is equals to 0 over 4 is 0. So if you found out that b squared plus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. So again, the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared plus 4 times a times c divided by 2a. In our specific quadratic equation, that is to say b squared plus 15b plus 50 equals to 0, the variable that we are looking for is b. So x equals to b. The coefficient a equals to 1. The coefficient b equals to minus 15. And again, the coefficient b equals to minus 15. And the coefficient c equals to 50. So actually, the only thing that is left to do is to put this data for our specific quadratic equation in this general formula for x, and in this way we find out the value of the values of b, because x equals to b according to our definition. Okay, so we do it now, and again that again x equals to b, therefore we substitute x by b. So b equals to minus b. The coefficient b equals to minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a times c. A is 1, so minus 4 times 1 is minus 4 times c. C is 50, so minus 4 times 50 is minus, again, minus 4 times 50 is minus 200 divided by 2a. A is 1, so 2 times a is 2 times 1, it is 2. So if you found out that b equals to 15 plus minus, inside the root we have 225 minus 200, it is 50. And again, let's go to inside the root we have 225 minus 200, that is 25, divided by 2. So b equals to 15 plus minus. The square root of 25 is 5 over 2. So here we have two solutions that are possible for b. So we define the first solution for b is b1 and the second solution for b is b2. So the first solution for b is b1 equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So according to the first solution of b is b equals to 10 units. So b1 equals to 10 units. And also have a second solution for b. The second solution for b is b2, and b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So if you found out that b2 equals to 5, so we have two solutions for b. The first solution for b is b1 equals to 10, and the second solution for b is b2, that is 5. We know that AD is one side of trapezoid ABCD, and AD equals to A, that is 14 minus 2B. So I want to know AD equals to A, and A equals to 14 minus 2B. AD is one side of trapezoid ABCD, therefore AD is a length, it must be a positive number. So AD equals to A equals to 14 plus 2B, it must be a positive number. It's a length, it must be a positive number. What is a positive number? A positive number is greater than 0. If it must be a positive number, it means that it must be greater than 0. That is to say, 14 plus 2b must be greater than 0. Here we'll add 2b to this inequality, and you get that 14 is greater than 2b. Here we divide this equation by 2, and you get that 14 over 2 is 7, so 7 is greater than 2b over 2 is b. So if we found out that B must be less than 7 units, but according to the first solution for B, B is greater than 7 units, because it is equal to 10, it is greater than 7. So this solution is the correct solution. You can set the solution, and you have to with the second solution that is possible for B, that is B equals to 5. So if you found out that B equals to 5 units, MC equals to B minus 2, B is 5, so B minus 2 is 5 minus 2, that is 3. So line segment MC equals to 3 units instead. And what is the length of DC? DC in total equals to 2 plus 3, that is 5. So DC equals to 5 units in its length. What is the length of AD? AD equals to A, and A equals to 14 minus 2B. B is 5, so minus 2B is minus 10. So A equals to 14 minus 2B, that is 14 minus 10, that is 4. So AD is equals to A is equal to 4 units, that is to say AD is the height of trapezoid ABCD, that is 4 units. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? We know that the area of any trapezoid actually equals to the sum of its 2 parallel bases times the height over 2. Therefore, the area of trapezoid ABCD must be equal to the sum of its 2 parallel bases times the height over 2. The 2 parallel bases are AD and DC. So the sum of those 2 parallel bases is AD plus DC. AD is 2, DC in total it is 2 plus 3, that is 5. AD plus BC is equals to 2 plus 5, that is 7. Times the height, that is 4, divided by 2. So the area of trapezoid ABCD equals to the sum of its 2 parallel bases, that is actually AB plus DC, times the height. The height is AD divided by 2. Which again, the area of trapezoid ABCD equals to the sum of its 2 parallel bases times the height over 2. So AB is 2 plus DC. DC in total it is 2 plus 3, that is 5. This is 5. So it is 2 plus 5 times the height AD. The height AD is 4 divided by 2. So in total, the area of trapezoid ABCD equals to 2 plus 5, that is 7. And then we have 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So if we found out that the area of trapezoid ABCD equal to 14 square units. Repeat again. Found out actually that the area of this trapezoid ABCD is equal to 14 square units. So finish with the first question. In the next step, I will present to you the second question. And we solve the second question of this lecture. Okay, the second question is also to find out in the second question the area of another trapezoid with the same name, that is trapezoid ABCD. They have both the same name, but they're totally different from each other. So what we have to find out the area of another trapezoid. So actually, this is trapezoid ABCD. This trapezoid ABCD. Side AD equals to 2x units in its left, side BC equals to x units in its left. This is 97 VM, this is equals to 2 units. This is 97 AM, that is equals to 3 units. Those two angles are both right angles. This is also right angle. Angle A and B is also right angle. Again, our mission is to find out the area of this trapezoid ABCD. Okay, so first of all, we define this angle. This is actually angle BMC as alpha. And we focus on this small right triangle, triangle MBC. In this small right triangle MBC, this angle equals to alpha. This angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. We also know that according to rule 3, the sum of the angles on one side of a straight line is equal to 180 degrees. But again, according to rule 3, the sum of the angles on one side of a straight line is equal to 180 degrees. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line DC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, this angle is equals to 90 degrees, plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Actually, the implementation of rule 3 in our drawing is that the sum of the angles of the upper side of the straight line DC at point M must be equal to 180 degrees. So therefore, this missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of DC at point M, exactly according to rule 3. So this missing angle must be equal to 90 degrees minus alpha. In the right triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Okay, therefore this missing angle must be equal to alpha. It is very easy to say from the drawing that those two right angles, that is to say the right big triangle ADM, the right big triangle ADM, and this right small triangle BMC, They're actually similar to each other according to angle similarity rule. Why they are similar to each other? Because in both triangles we have angle alpha, in both triangles we have this right angle, and in both triangles we have 90 degrees minus alpha. Therefore they are similar to each other according to angle similarity rule. So I write it down. This is the big triangle ADM. And it's similar, this is the side of similar to this right small triangle BMC according to angle similarity rule. Those two right angles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side AD of this right big triangle ADM over side MC of this small right triangle MBC is equal to side DM of this right big triangle ADM over side BC of this right small triangle BCM. And again, we derive that side AD of the big right triangle ADM or side MC of the small right triangle BMC equals to side DM of the big right triangle ADM or side BC of the small right triangle BMC. And we also derive that it equals it is equals also to side AM of this right big triangle AMD over side BM of this right small triangle BMC. So in total, we derive that AD over MC equals to DM over BC, and it is also equals to AM over BM. AD is 2x over MC. MC is the missing side, so we leave it as it is. And it is equals to DM. DM also is the missing side, so we leave it as it is. Over BC. BC equals to x. Therefore, we substitute BC by x, and it is also equals to AM. AM is 3 over BM. BM is 2. So in total, if you found out that from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. That 2x over mc equals to dm over x equals to 3/2. Those two expressions are equal to each other, therefore we get equation 1 from those two expressions that are equal to each other. So we get that 2x over mc equals to 3/2 according to the first equation. So x over mc equals to 3/2. So here we multiply this equation by mc, and we get that two x equals to 3/2. Again, 2x equals to 3/2 times mc. Here we multiply this equation by 2 and we divide it by 3 simultaneously, and we get that two x times 2 over 3 equals to mc. Two x times 2 is 4x, so 4x over 3 equals to mc. So if you found out that mc equals to 4x over 3 units in its name, so I write it down in the original drawing that mc, this is line segment mc of side mc, that is equals to 4x over 3 units in its name. We continue to focus on this long equation, and again that those two expressions are equal to each other, therefore we get equation 2 from those two expressions that are equal to each other. According to equation 2, we get that dm over x equals to 3/2. This is to say, the second equation will be as follows: the dm over x equals to 3/2. So again, if you found out that according to equation 2, dm over x equals to 3/2. Here we multiply this equation by x, and finally we get that dm, that is inside dm, is equal to 3/2 times x. And again, if you found out that dm equals to 3/2 times x. This is the answer at the end, of sides dm is equals to 3x over 2 units in its length. In the next step, We will implement the Pythagoras theorem on this small triangle BCM. So for the small triangle BCM in the equation, we will implement on it the Pythagoras theorem. Here by PT is the evaluation for Pythagoras theorem. So actually, this is the right small triangle BMC to the contour of the original moment. In this right triangle BMC, MC equals to 4x over 3, BC equals to x, and EM equals to 2. So according to the Pythagoras theorem, Bm squared, that is the square of the hypotenuse, equals to B squared, BC squared plus CM squared. So I already know Vm squared, that is the square of the hypotenuse, equals to BC squared plus MC squared. Bm is 2, therefore Bm squared is 2 squared, that is 4. And it is equals to BC squared. BC is x, therefore BC squared is x squared plus MC squared. MC is 4x over 3. Therefore MC squared is 4x over 3 squared. Again, MC is 4x over 3. Therefore MC squared is 4x over 3 squared. So if we found out that 4 equals to x squared plus 4x over 3 squared is 4x squared. It is actually 16x squared over 3 squared, that is 9. So total we found out that 4 equals to x squared plus 4x squared over 9, 16x squared over 9. So here we multiply x squared by 9 and then we divide it by 9 in order to find factor with these expressions. In total we get that 4 equals to x squared, so it will be 9x squared over 9 so it is 9x squared over 9 plus 16x squared over 9. So if you found out that 4 equals to 9x squared over 9 plus 16x squared over 9, so 9x squared plus 16x squared is 25x squared over 9. So in total, if you found out that 4 equals to 25x squared over 9. Here we multiply this equation by 9, so we get that 25x squared equals to 4 times 9 is 36. So here we divide this equation by 25 and you get that x squared equals to 36 over 25. So here we take out all this equation and finally get that x equals to the square root of 36 is 6 over the square root of 25 is 5. So in total, we have found out that x equals to 6/5. Okay, x equals to 6/5. Here, this is actually side BC is equals to x and it is equals to 6/5. Our mission is to find out the area of this trapezoid ABCD. So, according to the formula that I presented to you at the beginning of the lecture, the area of this trapezoid ABCD the area of trapezoid ABCD is equal to the sum of its two parallel bases times the height over 2. This trapezoid ABCD, the base ID is parallel to the opposite side of trapezoid ABCD, that is BC. So AD is parallel to BC. So the sum of its two parallel bases will be AD plus BC. Times the height of this trapezoid ABCD is DC because of the fact that those two angles are right angles and side DC makes 90 degrees with the base AD and also makes 90 degrees with the base BC. So therefore the height of of tablet ABCD is DC over 2. So now tablet ABCD equals to the sum of its two parallel bases, that is AD plus BC, times the height, that is DC over 2. AD equals to 2x plus BC, that is x, times DC, that is the height. The height DC equals to 3x over 2 plus 4x over 3. Okay, so in total, if you found out that the area of the ABCD equals to 2x plus x times 3x over 2 plus 4x over 3 divided by 2. So here we have 2x plus x is 3x, and also 3x over 2 plus 4x over 3. So here we multiply both the numerator of this expression by 3. I get that 3x times 3 is 9x, over 2 times 3 is 6. And you have to multiply this expression, both the numerator and the denominator, by 2 in order to become a factor of 6 with the other expression. So 4x times 2 is 8x divided 8x over 3 in order to divide all by 2. So in total, the area of tablet ABCD is equal to 3x. Inside the brackets we have 9x plus 8x is 17x divided by 6 and also by 2. So in total, if you found out that the area of ABCD equals to 3x times 17x over 2 times 6. So we divide both the numerator and the denominator of this expression by 3 and get that 3x over 3 is x, so until this side of the equation left only again it is 3x times 17x, so 3x over 3 is x, so in total in this side of the numerator of this expression we left only with x times 17x, and we have to divide the denominator also by 3. 6 over 3 is 2, so in total in the denominator we left only with 2 times 2. 2 times 2 is 4, and we also in the denominator 17 times x times x. So the area of trapezoid ABCD equals to 17x squared over 4. But we already found out that x equals to 6/5. Again, x equals to 6/5. So we substitute x by 6/5, and that will be the answer to the question. So in total, the area of trapezoid ABCD will be equal to 17 over 4 times x, that is 6/5, and times x again, that is 6/5. So in total, the area of trapezoid ABCD equals to the area of trapezoid ABCD equals, here we have equals to, we have 6 times 6, that is 36, and 36 over 4 is 9. So in total, the area of trapezoid ABCD equals to 17 times 9 over 5 times 5, that is 25. So the area of trapezoid ABCD equals to 17 times 9 is 153 over 25. 153 over 25 is 6.12 units. Okay, that is the answer to the second question. So in the next step, I'm starting the lecture. Let's start with the first question, of course. In the first question, our mission is to find out the area of this trapezoid ABCD. A trapezoid is a quadrilateral with one pair of parallel sides. Again, a trapezoid is a quadrilateral with one pair of parallel sides. A side AB is parallel to side DC. If we define the length of side AB as B and the length of side DC as A, then the area of this trapezoid will be equal to A plus B, this is the sum of its two parallel bases, times the height edge over 2. The height must get and the width with the other two bases. Okay? So it is given as the question that AB equals to 2, and you also know that DC equals to CB. And you also know that the perimeter of this trapezoid ABCD is 16. So it is given as a question that AB equals to 2 units. Use left, and BC equals to BC, and the perimeter of this trapezoid ABCD is 16. That is to say, what is the perimeter of a trapezoid? The perimeter of a trapezoid is the sum of the lengths of all the sides of a trapezoid. Again, the perimeter of a trapezoid is the sum of the lengths of all the sides of a trapezoid. So in this trapezoid ABCD, the perimeter is AB plus AD plus DC plus CB, and it is given the question that the sum of the lengths of all the sides of this trapezoid ABCD is 16. That is to say, AB plus AD plus DC plus CB equals to 16. AB is 2 according to what is given in the question. AB is 2. We define the length of side AD as A. We define the length of side DC as B. And because of the fact that DC equals to CB, according to this given equation, CB must be also equal to B in its length. So, we know that AB is 2, AD is A according to the definition, DC is B, and CB is also B. Again, AB is 2, AD is A, DC is B, and CB is also B. And in total is equal to 16, that is the perimeter of our trapezoid. So here we substitute 2 from this equation, if I found out that 16 minus 2 is 14, and inside of the equation we have to leave A plus 2B. So in total we found out that A plus 2B equals to 14. So we can write here that AD is equals to 8 is equals to 14 minus 2B. The next step we did a construction, that is to say, from this vertex B of trapezoid ABCD we go perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to construction. We define the touching point of the perpendicular from point B in DC. This point is point M. And when doing this construction, we're going to do quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the side of this 4 fixed again, in total must be equal to 360 degrees according to the rule that says that the sum of the angles in the quadrilateral is equal to 360 degrees. Therefore, this quadrilateral, if 4 right angles, it will be defined as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle AB and D, side AB must be equal to the opposite side DM. But AB is 2, therefore the opposite side DM must be equal to 2 right in its line. Likewise, according to the sum rule, with the sum of rectangle AB and D, side AD must be equal to the opposite side BM. But AD is 14 minus 2B, the opposite side BM must be also equal to 14 minus 2B in its length. So here we have what is the length of this missing line segment MC. MC equals to DC minus DM. Again, MC equals to DC minus DM. So MC equals to DC, that is B according to the definition, minus MD or DM. DM is 2. So in total, this line segment of side MC equals to B minus 2 in its length. So in the next step, I copied this right rectangle AMC in the page and implemented the Pythagorean on this right rectangle AMC. So this is the right rectangle AMC that I copied triangle BMC that I copied from the project domain. According to the Pythagorean theorem, in this right triangle BMC, BC squared, that is the square of the square of the hypotenuse, is equal to BM squared plus MC squared. BC is 14 minus 2B, therefore BC squared is 14 minus 2B squared plus B minus 2 squared. So in total, if we found out that B squared equals to 14 minus 2B squared plus B minus 2 squared. We compare the brackets of this side of the equation and found out that B squared equals to, we have 14 minus 2B squared. 14 minus 2B squared equals to 196 plus 2B squared, that is 4B squared, plus 2 times 14 times minus 2 times 14 minus 2b, this is minus 50, 56b. So in both sides of this equation we have b squared, so b squared will get cancelled. So because of b squared, this side of the equation we have nothing. This is to say 0. On the other side of the equation we have 196 plus 4, that is 200. And we also minus 56x plus 4x is 17. Again, we have in this side of the equation we left nothing after term cancel b squared. Well, on the other side of the equation we have 196 plus 4, that is 200. And we have also minus 56x plus 4b is minus 60b. And we also so in total 0 equals to 200 minus 60b, and we also 4b squared plus 4b squared. So here we divided this equation by 4 and finally found out that 4b squared over 4 is b squared, and we have minus 60b over 4 is minus 15b, and 200 over 4 is 50. So in total, if we found out that b squared minus 15b plus 50 equals to 0. So this is the quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the number that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, and the value that we are looking for is b, so x equals to b. The value of coefficient a is 1, the value of coefficient b is minus 15, and the value of coefficient c is 50. So the only thing that is left to do is to put this data for our specific quadratic equation inside this general formula for x, and we find out the value of the values of b, because x equals to b. So here we actually did it, and we put this data inside the general formula for x, and we found out that actually that x is equals to b, so we substitute x by b, and it is equals to minus b. The coefficient b is minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225. And we have also minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c is 50, so minus 4 times 50 is minus 200. So in total, if you found out that b equals to 15 plus minus square root of 225 plus 200. So inside the root we have 225 plus 200, that is 25. And this root is 25 is 5. So in total, if you found out that b equals to 15 plus minus the square root of 25 over to the square root of 25 is 5. So in total, if you found out that b equals to 15 plus 15, b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. The first solution for b is b1, this goes to 15 plus 5 over 2. B1 equals to 15 plus 5 over 2. This is the first solution for B. So 15 plus 15 is 20, and 20 over 2 is 10. So B1 equals to 10 units in its length. And the second solution for B is B2. This is equals to 15 minus 5 over 2. 15 minus 5 is 10, 10 over 2 is 5. So the second solution for B will be equals to 5. Okay. And we know that AD is a length is one side of trapezoid ABCD, therefore it is a length, and as a length it must be a positive number. So AD is equals to A, and A equals to, what we also know, that A equals to 14 minus 4B. Again, AD equals to A equals to 14 minus 2B. AD is a left, therefore it must be a positive number. Therefore 14 minus 2B must be a positive number. What is a positive number? It is a number that is greater than 0. Okay. So, if you found out that 14 minus 2B is greater than 0, here we divide this equation by 2. If I found out so, again we have the inequality that 14 plus 2b is greater than 0 because of the fact that the left one, 14 plus 2b is the length of this side AD, and as a length it must be a positive number. So this expression must be a positive number because it is the length of side AD. So it must be greater than 0. Here we divide this inequality by 2 and find out that 14 is greater than 2b. Again, we added 2b to the equation, we should find out to this inequality and found out that 14 is greater than 2b. Here we divide this equation by 7 and found out that 7 over 2 and 14 over 2 is 7 and 2b over 2 is b. So today we found out that b is, must be less than 7. But according to the first solution for b equals to 10, that is greater than 7. Therefore, this solution is a correct solution. And we focus on the second solution that is possible for b, that is b equals to 5. So here a equals to 14 minus 2b, and b is 5, so minus 2 times 5 is minus 10. So time b minus 10 is 4. So AD equals to 4, AB equals to 3, and this equals to 2 plus 5 minus 2, that is 3. So this in total equals to 2, and MC equals to b minus 2. B is 5, so b minus 2 is 5 minus 2, that is 3. So in total this equals to 2 plus 3, that is 5. Here this equals to 5. And we have, so AB equals to 2, this equals to 5, and AD equals to 4. Our mission is to find out this trapezoid ABCD. So the trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AB plus DC times the height, that is AD over 2. And again, the trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC times the height, that is AD over 2. AD is 2, and we will find out that this is 5, and we will find out that AD, that is the height of trapezoid ABCD, is 4 divided by 2. 2 plus 5 is 7, so, and 4 over 2 is 2, so in total this expression equals to 7 times 2, that is 14 square meters. So in total, if we found out that the area of this trapezoid ABCD is equal to 14 square meters. So we finish with the first question. In the next step, I will go to the second question and solve the second question in this lecture. In the second question, our mission is to find out the area of another trapezoid with the same name ABCD, but it is totally another trapezoid. So we know that AD equals to 2x, BC equals to x, and we also know that those two angles are right angles. This is again A and B. It is also a right angle, and again we also know that line 7 AM equals to 3 and line 7 BM equals to 2. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we define the size of this angle BMC is alpha. So in the right angle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third recent angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in a triangle. So we also have rule 3 that says that the sum of the angles from one side of a straight line is equal to 180 degrees. So this is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line, this is point M, here the sum of the angles must be equal to 180 degrees according to rule 3. So which angle at the upper side of this is point M, we have this angle that is alpha plus this is the right angle plus this missing angle, and total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees, that is the sum of the angles in a triangle. So this missing angle must be equal to 90 degrees minus alpha. In the right mixed triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in a triangle. In the next step, we prove that those two triangles, it is very easy to see that those two right triangles are similar to each other. Why? In both triangles we have angle alpha, in both triangles we have this right angle, in both triangles we have this angle that is 90 degrees minus alpha. So therefore, we found out that the big triangle ADM is similar to the small triangle BMC according to angle similarity. Again, the big triangle ADM is similar to the small triangle BMA according to angle similarity. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. Side AD over MC equals to DM over BC equals to AM over BM. AD is 2x, MC is the missing size over limited cities, DM is the missing size over limited cities, and BC is x. AM is 3 and B is 2. So in total we found out that 2x over MC equals to DM over x equals to 3 halves. So if we Those two expressions are equal to each other, therefore we get the equation 1 from those two expressions that are equal to each other. According to equation 1, 2x over mc equals to 3 halves. Here, we multiply this equation by mc and find out that 2x equals to 3 halves times mc. Here, we multiply this equation by 2 and we divide it by 3 simultaneously in order to find out the value of mc. So mc equals to 2 times 2x times 2 over 3. 2x times 2 is 4x, so total this expression equals to 4x over 3. So in total, if you found out that the length of line segment MC is the length of line segment MC is 4x over 3. Those two expressions are also equal to each other, therefore we get the equation 2 from those two expressions and they are equal to each other. According to equation 2, dm over x equals to 3 halves. According to equation 2, dm over x equals to 3 halves. Here we multiply this equation by x and finally found out that dm equals to 3x over 2. dm equals to 3x over 2. Our mission is to find out the area of this trapezoid ABCD. So in the next step, I copied this right angle BMC in the page and implemented the Pythagoras theorem on this right angle BMC. So here, this is right angle BMC, this is according to the original drawing, according to the Pythagoras theorem. This was a right angle BMC. Bm squared, that is the square of the hypotenuse, equals to BC squared plus MC squared. Bm is 2, therefore Bm squared is 2 squared. That is 4. And it equals to BC squared. BC is x, therefore BC squared is x squared. And we also plus MC squared. MC is 4x over 9. Therefore, MC squared is 4x over 9 squared. So in total, if you found out that 4 equals to x squared plus 4x over 3 squared. So 4 equals to x squared and 4x over 3 squared is 16x over 9. In the next step, we multiplied x squared by 9 and then we divided by 9 in order to become factor of this expression. And if we found out that 4 equals to 9x squared over 9 plus 16x squared over 9. 9x squared plus 16x squared is 25x squared. So in total, and in the denominator we have 9. Okay, so here, actually found out that 4 equals to 25x squared over 9. Here we multiply this equation by 9 and finally found out that 4 equals to 25x squared over 9. So here we multiply this equation by 9 and we found out that 25x squared equals to 46. Okay. Here we divided this equation by 25 and finally found out that x squared equals to 36 over 25. Here we took out all this equation and finally found out that x equals to the square root of 36, that is 6 over square root of 25, that is 5. So if you found out that found out the 3 that x squared equals to 36 over 25, so to go to all those equations and found out that x equals to the square root of 36, that is 6 over square root of 25, that is 5. Okay, so x equals to 6/5. Our mission is to find out the area of this trapezoid ABC. area of this trapezoid ABCD. So what is the area of trapezoid ABCD? The area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually AD plus BC, times the height, that is DC over 2. So again, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually the area of trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AD plus BC, times the height DC over 2. AD is 2x, BC is x, and DC, the IDC is total, it is 3x over 2 plus 4x over 3 divided by 2. 2x plus x is 3x, and here we took 6 as a common factor out of this expression, so I should hold on that x squared plus 9x plus 8x equals divided by 6 and divided by 3 also, or divided by 2. So we have here 9x plus 8x, that is 17x. So in total we should find out that the area of trapezoid ABCD equals to 3x times 17x over 2 times 6. Here we divided both the numerator and the numerator of this expression by 3, and finally found out that 3x over 3 is x, and 2 times 6 we have 6 over 3 is 2. So in total in the numerator we have 2 times 2. So in total if you want to know that the area of trapezoid ABCD equals to x times 17 times x over 2 times 2. 2 times 2 is 4, so the numerator we have 4, and the numerator we have so if you find out that x times 17 times x equals to 2 times 2, that is 4. So in total the area of trapezoid ABCD equals to 17 times x over 4. We already found out that x equals to 6/5, therefore we substitute x by 6/5. And we found out that x equals to 17 over 4 times x, that is 6/5, and times x again, that is 6/5. We have 6 times 6, that is 36, and 36 over 4 is 9. So we can set this number, and it's not 6 times 6 over 4, go down 9, because 36 over 4 is 9. So in total the area of trapezoid ABCD equals to 17 times 9 over 25. 17 times 9 is 153 over 25. So if you found out that the area of this trapezoid ABCD is equals to either 153 over 25 square meters, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square meters. Okay, thank you very much.